All right, we're live. I'm joined today by Alex. My name is Sunny. This is the Sunny Ray Show. Thanks to our sponsors, Raz Rocket. Alex, where are you calling in from today?
New Jersey,
New
when
Jersey.
we still have snow, believe it or not. Plenty of it,
New.
actually.
Cool, cool. Hey, so the title is quite intriguing. The Black Box Problem: How One Founder is Stopping AI from Going Rogue. Why don't you just maybe with the audience before we even dive into everything, just share one or two sentences on what you guys do at the company, and then we'll make sure that before the end of the interview we spend some time
Sure.
on it as well. Yeah.
So, in a nutshell, we do detection and response for AI events. And an AI event can be as simple as a chatbot, right? We call it user to LLM. So you have a prompt and a response, and there's a back and forth between the user and a large language model, um, up to hierarchical multi-agent agentic workflows where you have different events, right? The agent might talk to its memory, to another agent. It might pull content from the internet. It might execute a tool. So these all constitute events for us. And our job, as I said earlier, detection and response is to actively monitor these events and and detect safety and security issues, whether it's disclosure of PII, PHI, or PCI, health, payment or personal information, or active attacks against the model.
Fascinating. Alex, you've said you started coding. I mean, just to set some context, thank you for sharing that. I wanted to just kind of rewind a little bit, talk about, your backstory before you got into entrepreneurship and all this. But I was reading about yourself this morning, and I was reading that you started coding BASIC on a Commodore 64 at the age of
Yeah, you're
8.
aging me now. That's correct. Yeah.
Hey, that's pretty cool. That's pretty cool. I mean, I grew up in the, what is it, 386 era. I don't know
Uh-huh.
if you remember that one. What was it about that machine, the Commodore 64, that grabbed you? Were you the kind of kid who essentially wanted to understand how things worked, or did you stumble upon it? What did that look like?
My dad, one of his first jobs, he worked for IBM, and I remember as a kid, he had this massive terminal in the basement, and this was I was maybe 5 or 6, and this was my first kind of touch point with computers. And as I grew older, I got more and more fascinated with it. The Commodore 64 was an awesome device because it was easy accessible. You had the ability to play games, which for a kid obviously is a big deal. But then it also, opened up the opportunity to actually discover more than just playing games. To your point, writing basic software. I remember back at the school, I would write simple software that takes time for the running races at the school and things like that. I guess it's the magic. It's the discovering new things on a daily basis and not knowing when it ends and where it will end. I think this is what always fascinated me with computers at the time, that it seemed to have unlimited possibilities.
So true, so true. Yeah, I'm so grateful that my dad got me those early computers, and yeah, it's really shaped the arc of my life. So growing up in Austria, what was the tech scene like when you were coming of age? Was there a moment when you realized that tech could actually become a career and not just a hobby?
Well, Austria never had a big tech scene, right? Austria is famous for many
Right.
things, but I don't think it's necessarily high tech or IT. I lived abroad quite a bit. My parents were expats, so I only spent parts of my childhood in Austria. I worked at the first internet service provider. So 98, 99, I ended up with a small company that was actually building the first internet service provider. Europe was a bit behind, probably a couple of years in sense of early internet adoption at the time. And we would literally, there was no Cisco remote access servers available. We would literally buy modems and Velcro them on the office wall, and then have a Windows NT server with RAS servers, to provide, internet service to the first early users. So that was kind of a early touch point with the internet. But there is basically, or at the time at least, there was no risk capital or venture capital for anything IT or digital related. It got a bit better, but I would not necessarily say that it is an innovation hub even today.
And so you started your professional career as what they called a programmer,
Yeah.
doing mainframe automation projects. So what was that world like? And what did working on mainframes teach you that still sticks today?
So my job at the time was to use 3270 emulation, Hummingbird, for those who were around at that time already, and basically start automating the mainframe using a PC. So we would write software that would allow mainframe users an easier, even graphical user interface with which they can control the mainframe. What I learned at the time is that coding is not my future. And I remember I was, spending a lot of time writing code, and then the company hired a mathematician to optimize my code. So my code would work, but it was not fast enough, right? So there were times where you would learn things like bubble sort and stuff like that. But the learning event for me was that I can never be the best in coding because I lacked some of the math foundations and some of the classical coding foundations. That's why they brought in a mathematician. So I still do coding, every now and then, but that was a learning or point in time for me where I said, maybe coding is not the final path for me. And this is actually when I got more and more interested in network tech. And that, to my earlier point, led to start working for that internet service provider.
Very cool. Very cool. And then the internet boom hit Austria, and you made a pivot from coding to networking, right? Eventually landing at Cisco. So what made you decide that networking was more exciting than development? And what did, Cisco teach you about large scale
Well,
tech?
it's a bit the new shiny thing, right? And I think we're all susceptible to a certain degree to it. So after spending 3-4 years in coding, internet came up, routers came up, people needed engineers that knew how to code or to program iOS on Cisco devices. So it was probably the new shiny thing. The possibilities it presented. We were asked early at the time to support a local bank in Austria for some pen testing, which you can imagine, when you're 22 years old and the bank says, hey, come and, give it a try, see if you can hack us. It was a tremendous amount of fun, obviously. That kind of, I think, was the pivot, that it was new, that it seemed, unbounded, unlimited in its possibilities. And this is how I kind of got deeper and deeper into network tech and eventually worked as a freelancer for Cisco.
So between Verizon, Zenki, Eclipse, you've led teams across, cybersecurity, digital identity, and enterprise tech. So you also teach as an adjunct professor at the University of Houston and Missouri S&T. So just what drives you to stay connected to academia while also running companies? And what do students teach you that maybe the corporate world doesn't?
When we founded AISpark, we quickly realized that as a startup, we can't afford hiring, machine learning engineers, data scientists, because even at that time they were already very expensive, talent. So we started this cooperation with the University of Houston. A friend of mine at the time was a department chair there, and we basically built our own talent pipeline. So, we had access to all the students, we interviewed students, and we basically got the 10 most, promising students into the lab, and 6 of them are actually employed today, right? They finished their masters with us, they started working for us, and that kind of drew me deeper into academia, in sense of that I probably never appreciated how much of a powerful resource pool, especially for emerging tech, it can be. There is a price, obviously, right? You get young folk that work in their first job, so they might need more coaching than a bit more mature employee. But the upside is you get let me call it a fresh brain that so often looks at problems with a very different perspective versus myself, having been around for quite some time and might be biased towards certain tech solutions or viewpoints. So we learned a lot, or I personally learned a lot working with students, simply because they often have a completely fresh and novel way of looking at problems, if that makes sense.
Oh yeah, absolutely. Absolutely. So after 2 decades in cybersecurity and enterprise tech, what was the specific moment or experience that made you think, I need to build something new in AI safety? Was there like a particular incident, a conversation? And, yeah, what kind of tipped you over the edge?
I did. I was always, involved in AI to some degree in the cybersecurity sphere, right? So we saw, when was it, 7, 8 years ago, AI basically emerge in legacy classical cybersecurity, right? Unsupervised learning, we saw it coming into the endpoint. And as I did more and more of my own learnings in AI and got into deep learning and neural networks, I got fascinated with the idea of, well, how will we as humans, as this accelerates and moves forward, keep control if we can't understand how these models basically operate? So the idea of AI explainability, meaning the ability to fully comprehend how an input produces a certain output, interpretability / explainability. I got more and more interested in, and I raised $1 million to stand up basically the company and the lab in Houston. And we started as a research project on AI explainability. So we're basically reverse modeling deep learning and neural network based architectures to understand how to explain them. GPT was launched, everything pivoted towards GenAI. And we kind of realized that the ability to have an explainable safety security stack as AI accelerates might be something important as the technology.
Maybe. Oh my goodness. Yeah. So you've talked about the problem of using, one black box to monitor another black box, using, LLMs to secure LLMs. When did that insight crystallize for you, and why do you think so many companies fell into that trap?
So I think let's make a step back, right? Let's forget AI. Just think of this way: you discover a highly advanced technology. Would you use the same advanced technology to protect yourself from that technology? I think intuitively it kind of makes sense that this might not be the best course of action. And that's basically the basic premise is, if you have a highly advanced technology that has benefits but equal risks, do you use that same technology? Do you trust that same technology from keeping you safe from adverse effects, right? Obviously, our opinion is the answer is no. I think I wouldn't call it a trap in sense of the space is so new and novel that a lot of people simply, don't know the difference between an LLM-based assessment and a machine learning-based assessment, right? I remember last year, the sales calls, we spent more time on education than actually actively selling, right? Because it's such a novel and new space. A lot of people like the outputs from LLMs that are securing LLMs because they're very verbose, right? We use machine learning, good old-fashioned machine learning, so we give you full explainability, but we never gave you the verbosity of an LLM response that explains itself as to why exactly it's a jailbreak and so on and so forth. So I think there's a future where we start combining fully explainable deterministic assessments with some degree of generative AI, where we kind of split between for lack of a better word, the ground truth coming from an explainable deterministic model, but the verbosity and the additional context coming from a large language model or small language model or generative model in general, if that makes sense.
Yeah, absolutely. Very interesting. You also have drawn a parallel between the regulatory lag with the internet, right, and social platforms to what's happening with AI, right? You said that society can't afford another decade-long gap. What specifically about AI makes the timeline more compressed and the stakes higher?
The fact that it has a vast potential to be fully autonomous. So, the internet as well as social media, they were still designed by humans deterministic in a way that they could never do anything that was not programmed into their capabilities, right? A social media algorithm, would never evolve on itself. It is designed for a specific purpose, so it operates within specific boundaries. The fact that it created, specific societal harm and all the issues we see is a different issue. It's a human-made issue ultimately. With AI, it's the fact that we really transfer agency, right? We do not deterministically program or code or set the pathway and the limits of the application. We transfer agency. We give agency to AI to perform increasingly more complex tasks. So now the debate starts, is it actually intelligent? Is our brain actually doing the same in sense of being a high performant probabilistic engine that predicts every word? And therefore you now see basically people on the one side saying it's still a, it's still a dumb model, versus others suggesting that there is, that these models show some degree of intelligence. If I look at reports, I think Anthropic had a couple of months back, they had this experiment, remember, where they basically told it you're going to be switched off, and it really started showing adverse behavior. The question is, how did it learn that? How did it come about this behavior, right? Is it purely by ingesting so much language that linguistically or semantically, that is the only response based on what it has learned? Because it has learned that being switched off or fired or being redundant is a bad thing and you should try to avoid that? Or is there more, right? And because we can't explain and interpret these models, it's a very heated debate between it's still just a dumb machine, very efficient, right, and very effective in what it does, versus it shows the first signs of actual intelligence.
It's probably a dumb question, but like at the end of the day, these are transistors, these are ones and zeros. How did we arrive at this place where the whole world is using black boxes? Like, how is it that even the top people in the world are saying we don't understand really what's happening? Like, what can you kind of peel that back a little bit? Do you know what I'm saying? Like, how is it? How can we say that? Like, can't we just look at the circuits and be like, oh, there's electricity moving through this wire, and it's happening because of this input and that output? Like, where does the black box thing come in? Like, I know that's the case because everyone says so, but do you understand what I'm asking? Like, where is that complexity that it falls apart that humans can't decipher what these systems are doing?
Models, right? There is probably way better people and more qualified to speak about this than me. But large language models are ultimately transformers, are ultimately neural networks. Neural networks have multiple layers. They have a lot of components. Neurons. The idea was to simulate to a certain degree the function of the human brain. So you have a lot of neurons that basically have highly specialized functions, right? Gate functions, binary functions, and information trickles through so many layers, through so many neurons that perform operations, that what you get at the end, you cannot basically reverse engineer it, right? You can't say, based on this output, I can now reverse engineer and understand exactly what happened across the different layers, across the different neurons. Anthropic made some advancement.
Is it a complexity? Is it a complexity thing? Is it just because it's too complex we can't say it, or is it truly a black box? Like, might someday we be able to decipher what's happening? I mean,
I think so. Yes, there's a lot of research happening in alternate, AI architectures where there's one group that is pursuing what are they called? Modular artificial general intelligence, where the idea is that you build models that mimic specific parts and functions of the brain. The idea is there can't be a single model that can perform everything, so it goes into hyperspecialization, right? Where models that mimic or simulate the different functions in the brain, for example, work together. There's other research where around world models, right? So the idea is, if the model itself is not cognizant of its world, of its surrounding, of its context, it will always have a limit in efficiency and efficacy to a certain degree. And
cool.
Part of these is, sorry, the long answer. Many of these researchers include, how do I make it explainable by building the architecture from scratch as being explainable? So the short answer is yes, to a large degree. It's the speed and complexity at the speed it's happening. It is not possible for us to explain or interpret.
So for someone hearing about Iceberg for the first time, walk us through it simply. An enterprise, let's say they're using, I don't know, ChatGPT, or they've built some customer-facing chatbot, or they're deploying autonomous AI agents. What exactly does Iceberg do in each of these scenarios?
So we help enterprises with 3 use cases. The first one is, as you said, I have 500 employees that have an enterprise GPT license. I need some degree of control. What is being shared with the public model? What it is being used for? So the big focus there is on data loss, right? On data loss and the exposure of sensitive corporate information. The second use case is application security, also what you just mentioned. I run a public chatbot. It is designed to help my customers with my product lines. And there we would sit in between, look at the input, look at the output, and determine safety and security. And the third use case is agentic AI. And with agentic AI, it actually starts way earlier than safety security. The first challenge is observability. So you have CEOs of large enterprises basically announcing that, we're all doing AI now, and every business department should start looking into, automating processes or driving innovation with agentic AI. So if you're a CISO, a Chief Information Security Officer, and there is no governance and program to cater for that, you now have every business department spinning up agents that are accessing tools, that are accessing data, that might be accessing public information and pulling this information. And that's scary because the CISO should not be the Department of No, how it was often perceived in the early days. So with agentic AI, it really starts with observability, the simple ability to know who is running agents and what are these agents doing.
Interesting. Actually, you raised a $10 million seed round from SYN Ventures in March of last year, and you said you're deploying the capital across go-to-market, R&D. What's the third pillar? Is there something else? Is there something outside of go-to-market and R&D? Are there some other things you're deploying the capital towards? What does the next 12 months look like in terms of building the team and the product for you?
So go-to-market is the majority that we're investing into. We spent over 2.5 years building this. So we have a research team, we have an applied data science team, and now really it's about translating all these capabilities into a customer-facing services and products. So go-to-market for us means a lot of investment into automation, right? So the ability of Gen AI is equally powerful, obviously, in sales. So we build a full RevOps platform that does, that uses agents that basically do account research, right? That score these accounts on ICP, that score them on readiness. Highly ready accounts go into a pipeline that then uses Gen AI to formulate a personalized email that goes out to the prospect, right? The prospect answers or not, we capture that answer, it goes into HubSpot. So RevOps for us is really using Gen AI and advanced AI capabilities to perform sales at a much higher cost efficiency. In other words, everything we're doing with RevOps today, 10 years ago, I would have to hire 4 to 5 people probably, just for what these agents and models are doing fully automated today. So that was a big piece of work and investment to make the best use of advanced AI capabilities for a startup. And there's also an interesting aspect of Gen AI and AI in sense of the democratization of startups to a certain degree. You can be, with very little capital, you can deploy a lot of advanced tech actually today. And build, your HR, sales, and other cross functions highly effective and cost effective.
Awesome. So thank you so much, Alex, for this time. You've been very gracious. I really enjoyed it. I think you're working on something that is incredibly important, and not enough people seem to be focusing on it. So thank you for the work that you do. And with that said, we can bring this stream to an end. Thank you all for tuning in, and until next time.
Thanks for having me, Sunny.
Hey, Alex, maybe just hang back.